Australian mathematics curriculum, index laws. We're covering multiplying, dividing, and brackets when we have powers. A reminder about indices. 2 times 2 times 2 can be written as 2 cubed. This is the index form. This is the expanded form. And if we wanted to evaluate it, 2 times 2 is 4, times 2 is 8. So we've evaluated 2 cubed is equal to 8. This is the index, sometimes called the exponent, and the 2 here is our base numeral. The whole thing is called a power. We can also have powers in algebra. A times A times A is A cubed. We can't evaluate it unless we're told what A equals, so we leave it in index form. In a question, if we're asked to leave an answer in index form, this or this is what we're after. Again, we have base number is A, index is 3, this is the expanded form. Our first law is the multiplication law. The easiest way to do this is if we look at an example, because all we're really doing with this law is finding a shortcut. 2 cubed times 2 squared. Well, 2 cubed, we know, is 2 times 2 times 2. And we need to multiply 2 cubed by 2 squared, which we know is 2 times 2. Now, if you look at what we've got there, actually that's 2 times 2 times 2 times 2 times 2. That's 2 to the power of 5. What this does is it finds us a shortcut, because we can see that our original question, 2 cubed times 2 squared, gives us that answer if we just add the indices. And so we know this shortcut exists, so we don't need to show this line of working. That line of working is useful if you forget how the index laws work. It will always help you find the right answer. So our multiplication law can be represented as I've done here. If we've got the same base number and powers of that base number are multiplied together, we can get the answer just by adding the indices. So my rule in words, if I'm multiplying powers with the same base number, my shortcut is to add the indices. Let's do some examples. Example 1, 10 cubed times 10 to the power of 4. If I expanded it out, it would be 10 times 10 times 10 times 10 times 10 times 10 times 10. But we know that we can take the shortcut of adding the indices, 10 to the power of 3 plus 4, 10 to the power of 7. We leave it in index form if the question asks us to. Next question, x squared times x. Now we'll learn later that anything that doesn't have a power actually has a power of 1. So to add the indices here, I've got x to the power of 2 plus 1, x to the power of 3. If we expanded that out, we'd see that we were correct. X squared is x times another x to the power of 3. With the last question, 3k to the power of 4 times 2k to the power of 5, we've put coefficients in. Coefficients, of course, the numbers in front of an algebraic term that we multiply them by. Well, remember we're allowed to rearrange multiplications. So this is really 3 times 2 times k to the power of 5 times k to the power of 4 times k to the power of 5. Rearranging it helps us realize that we need to multiply the coefficients. They're not part of the power. 3 times 2 is 6. And then deal with the powers, because we have the same base number of k. That's k to the power of 4 plus 5 is 9. So if we have coefficients in algebraic terms, we can multiply those as usual, then deal with the powers. The division law. Again, it's a good idea to look at an example. And the easiest way to deal with divisions is to write them as a fraction. So this is 2 to the power of 5 over 2 squared. If I expand that out, I have 2 to the power of 5, 2 times 2 times 2 times 2 times 2, divided by 2 squared, which is 2 times 2. Now we know from things we've done before that I'm allowed to cancel in a fraction. Cancelling out a 2 on the top and a 2 on the bottom, a 2 on the top and a 2 on the bottom. I've now cancelled out everything I can. I'm left with 2 to the power of 3. 2 times 2 times 2. And again, we don't have to do this expanded form here. We can look for the shortcut. When they said 2 to the power of 5 divided by 2 squared, we got our answer by subtracting the indices. 5 minus 2 is 3. So our division law, which again I can write as an algebraic rule, is when I've got numbers of the same base and my powers are divided, I can get the answer with a shortcut by subtracting the indices. So my rule in words, if I'm dividing powers with the same base, subtract the indices. Let's do a couple of examples. Y to the power of 9 divided by y to the power of 7. Now you can rewrite it as a fraction. It's good practice always to do so. Y to the power of 9 divided by y to the power of 7. But really here we can see that we just subtract the indices. 9 minus 7 gives me y squared. When we get to harder questions, it's a good idea to make sure it's in a fraction. Deal with the numbers, the coefficients, first. It's just a fraction that you'd need to simplify. When we simplify, we look for the highest common factor. In that case, it's 2. And we divide the top and bottom numbers by 2. 14 divided by 2 gives me 7. 4 divided by 2 gives me 2. So I've already got a fraction that's got 7 over 2. And then cancel my powers. B to the power of 8 divided by b, I get to cancel 1b from the top and the bottom. So in my answer, I've got b to the power of 7. So my answer is 7b to the power of 7 over 2. The last rule for this one is powers when I've got brackets. And again, we're going to work through an example to see why the shortcut works. Here I've got x squared to the power of 3, and the brackets say that x squared is to the power of 3. Well, I know that to the power of 3 means I've got to multiply the thing by itself 3 times, 2 multiplications, 3 of the object. And so that would expand out to be x squared times x squared times x squared. Now, if I expanded out those x squareds, which I am allowed to do, that's x times x is my first x squared, times x, that's my second x squared, times x, that's my third x squared. And you can see this is just an expanded form, x times x times x times x times x times x. That's x to the power of 6. We look for a shortcut rule, and we can see that I could get that answer by multiplying the powers. So the shortcut, if I don't want to write the whole expanded form to work it out, is that I multiply the powers. Effectively, I'm raising everything inside the bracket to the power outside the bracket. So my rule, algebraically, a to the power of m raised to the power of n means I multiply those indices. In words, if I've got a power outside the brackets, I multiply the indices of everything inside the brackets. So a couple of examples. X to the power of 3 raised to the power of 4. I remember my rule of multiplying. I've got x to the power of 3 times 4, which is x to the power of 12. Now we've got a little more complicated in the second example because a squared inside the brackets has a coefficient of 2. And you'll remember I said we multiply, or we raise everything in the brackets to the power that's outside the brackets. So I'm going to have to do 2 to the power of 3 times a to the power of 2 times 3. Now really I'm still multiplying this one because that 2 has a power of 1, and 1 times 3 is 3. But you can remember if it doesn't have a power, it just gets the power outside the bracket. Now if I've got a question that asks me to leave it in index form, I still evaluate the coefficient if it's an algebraic expression. So that equals 2 cubed, which we'll remember 2 times 2 times 2 is 8, a, and 2 times 3 is 6.